What's really nice about this is we had to give so much effort when we had it in standard form. We had to give so much effort to find the vertex. Remember, we had to do that negative b over 2a, find that, then plug in our x value. What's nice about this form, the vertex form, is that right off the bat we're going to be able to find what the vertex is just by the values that are given in this form. So this is really key. This is boxed out in your paper. It's larger than the other notes. This is what we're going to reference every single time. And we're going to learn 4 steps. 4 steps. Some of them are exactly the same from what we did last week. And I'm going to explain why I put this in kind of a double parenthesis situation here, because the one crux, the one tricky part of this has to do with this value in here, this h value. And even though there's quite a few variables, and now we have a, x, h, and k, don't worry about that, because when we're given the actual equations, when we're given our problems to solve, the h and the k values are going to be given to us. Okay, so this is just almost looking at this as like a formula that you have to really memorize with the syntax, with the order of and the position of these variables. It's like a map. Okay, think of it like a map. When we get to doing the problems, all you need to do is reference and figure out what the values are. So let's start off step 1. So just pretty much copied down to here so far. Good. And I put the step 1 over on this side. It's the same as what we did last time, except we're identifying different variables. So here we're identifying a, h, and k. That's step 1. When we just have to identify, it's not that bad. We don't have to be intimidated by that because it's a map. We look at the map and we can figure it out real quick. Let's find this with example 1. What is my a value? Where do I find it and what is it? Where do I find it though? So to help everyone else. What do you think? It's either too easy of a question or nobody knows. So where would I find my a value, Jonathan?
3.
3, and the a value is always located.
Distributing.
Right, it's the number you usually would distribute, but we don't have to manipulate this formula at all. It's actually just given straight. So it's the number it's a value that's in front of this expression here. It's always out in front, just like a when we had our standard form. It's kind of similar because it's the first value that's going to be given to us. So we know that our a is positive 3. Now what is my h value? Where do I find my h value? I look at my vertex form, it's x minus h. So if it's x minus h, the subtraction there is part of the form. So as I look over here, what is my h value? This might be this is the crux. This is the trickiest part.
It's 1.
What was it?
1.
1. Okay, so I know my h is equal to 1, not negative 1. It's 1 because the initial formula is x minus h. Okay, it's minus whatever that value for h is. The crux is going to get a little trickier for example 2. Let's keep going with this. What's my k? The k is nice. The k is always that value out here. K is 3. So I know this. It's always going to be this value if it's positive or negative, because I looked to my original map says that it's plus k, right? K can be positive or negative. It doesn't matter. So whatever number's out there is going to be my k value. This crux is a little different because we have a subtraction in here. When we have subtraction, we got to pay attention to the signs, but it's less relevant out here when we just have plus some value. So step 1 done. How are we feeling about step 1? Thumbs up, sideways, down. Okay, good. Step 2. This is great. Think of how much effort you had to do to find the vertex before. Here, the vertex is always equal to the coordinate hk. So watch how fast this is. I go back to my example problem. I write vertex. What's my h value? What's my k value? Done. That's why I wrote, yes, thank you. Why? Because it's that quick. We don't need to manipulate or change around this formula. It's set up in vertex form for us. If you're good with your algebra, you could totally switch that back into this form. And maybe that's if you want to give yourself a challenge. If this is going at a slower pace than you'd like, try to figure out how this comes from this form, the standard form. They're all related, just a little bit of algebra. Okay, so we have step 1, we have step 2. Step 3, we already know how to do this. It's the same exact thing. We're talking about the same shapes, parabolas. So if I look at my a value is positive. So just like before, when a is positive, what kind of shape are we going to have?
A smiley face.
Right, it's going to open up, smiley face, because a is positive. Opens up. So far we're doing pretty good. Mainly because we know these things already. We're good at identifying, and we'll practice that more. Vertex is just plugging in what you identified. We already knew that if a is positive, it's smiley. A is sad. A is negative. Okay. Step 4. Now I want you to think about this. The Y-intercept. The way we find the Y-intercept is by plugging in x is equal to 0. And what's nice is this is going to give us the answer really quick with this. So watch. F of 0 of my equation that I am working out here. 3 times x, sorry. Function notation tells me what? I'm going to plug in 0 for what?
X.
X. So I go right to that. 0 minus 1 squared plus 3. You see how that's going to be really quick to solve? We don't have much to do here. Now it's just arithmetic. PEMDAS. We can do that all day. So we have 3, negative 1 squared plus 3. 3 times 1 plus 3. 3 plus 3 is 6. Okay. So I just found my Y-intercept. My Y-intercept is 0 for x, 6 for y. Now we have enough to graph. This is what we'd end up with when we were graphing from standard form. Remember, we just needed the vertex. We needed the Y-intercept, which in that case was always equal to c, so that was always easy to find. And then we had to figure if it's up or down. From there on out, it's just line of symmetry breaks in half, and we can graph it from there. So all I did was identify A, H, and K. That helps me find the vertex, which is H and K. I went next and found that A was positive. It's happy face. It's going to open up. Next step, I need to find the Y-intercept, so I plugged in 0 for x, worked it out, found that when x is 0, y is 6. Okay. So remember, f of 0, f of 0 or f of x, it's aka, it's synonymous with the y. Okay. So when we're looking for f of x, we're really looking for y. It's just in function notation. So I know I've said that probably like 20 times last 2 weeks. I slowly will stop saying that. I think we'll get it. Okay. All right, how are we feeling? Thumbs up, sideways, down? Okay, good. Okay. So if you're feeling really confident, I still need you to focus on this next example problem because it has, it has the crux in it. That is a little bit harder. If you already see it, it's great. That's great. If you don't see it yet, we're going to get into it. What is my A value for example 2?
Negative 1.
Negative 1. I know this is a 1 here, so A is negative 1. Right off the bat, since I'm already dealing with A, does that mean it's going to be opening up or down? Happy or sad face?
Sad.
It's going to open down because it is negative. Okay, what is my, well, let's do the easy one. What's my K value?
4.
4. K equals 4. And now I have to look closer at my H value. Now, what is my H value and how did you figure that out? Somebody really straightforward, directly kind of share that. So,
It's 2.
it's 2. Anybody want to help out with that? Everybody else think it's 2? It's close to 2. It's its evil stepbrother.
I think it's negative 2 because if it's going to be like the one on the top, that means the negative would be distributed over it, and so that would make it positive 2. So then actuality is negative 2.
Great, and I'm going to explain a shortcut for that and how it works from our equation. So it is -2. Well explained, and I'm gonna keep going on what you said. All right. Look at our original equation. Our original equation isn't x combined with some negative number. It's x minus, there's an operation, minus an h value. That's part of the form. That's part of the formula every single time. So when I come over to this step, yeah, sure, if this was x minus 2, that'd be really easy to see. H is going to be positive 2 because it's just whatever value is right there. But instead it's plus 2. Because it's plus 2, I have to think about this. What value for h would I need to have in order for the standard formula to go from a subtraction to an addition? That's one way to think about it. I'll get the real shortcut in a second. You can always double check yourself as well. If you go and you take your guess, h is -2, and I re-input it just in this little part right here. I just input it right here, and we have x minus -2. Right, I input what my guess for h was, and then I can say, oh, okay, well that's x plus 2. Does this match where you started? It does. So there's a couple ways to double check yourself. There's ways to conceptualize it based on comparing the formulas, and there's a shortcut. And I share the shortcut not to depend on, but maybe for you to like reinforce that idea from this kind of breakdown here. Okay, so here's the shortcut. Very helpful to write the shortcuts. They're not random here. Okay, so if this is addition, so if it's addition, then your h is going to be negative. The reason being is, in order for it to change to be addition from subtraction, my h has to be negative. That's the only way I could end up with addition at that part of the formula. Okay? So who feels good about it if they were just using the shortcut? If it's addition, I know its h is negative. Who feels okay about that? Thumbs up, sideways, down? Okay. Who feels good about being able to look and see that just from looking at the formula that I end up with addition and I start with subtraction, so it just has to be negative? Who's feeling that route of logic? Okay, good. Okay. Who finds it helpful here to substitute it back in to see if you end up with that same situation as we start with? Is that helpful? Up, sideways, that's a down. Nobody's doing anything. All right. That's okay, that's a backup plan. I think just from the conceptual and the shortcut, we're gonna do well on that. This is the crux, that's the hardest part. It's the hardest part, because look, I have A, H, and K, now I can do what? Vertex, watch how fast this is. Vertex, -2, 4. Y-intercept. Find that really quick. Once you know A, H, and K, you know that vertex. How did I find the Y-intercept up here? What did I do? I did.
You replace x with 0.
Good. So we evaluate, we plug in, x is equal to 0, so I'm going to do that here. F of 0 is equal to -0 plus 2 squared plus 4. I hope that when you get to finding the Y-intercept, you know that the problem's almost done. Because here we don't have to do any algebra really. At this point, it's just doing arithmetic using PEMDAS. So if you forget that, or if you're like, yeah, PEM what? I want you to write PEMDAS. This is what we're doing for the Y-intercept. We're always using PEMDAS. Because it tells us what to do in order. If I look here and I didn't know what to do first, I might say, well, I like to multiply my negatives in there first. That's not going to be helpful. What do we do first? Within the parentheses, we can simplify that. What do we do next? Exponents, and I have an exponent right here. So I end up with -4, because 2 squared is 4. There's a negative out there already. And what happens when you have -4 positive 4? 0. So I know that f of 0 is equal to 0, so I have a y-intercept at 0, 0. Okay, let's look what we did. We identified A, H, and K. We were really careful because we had addition. I know that means the H is going to be a negative value. We found the vertex by just plugging in h and k. That's automatically the vertex. We already knew this, that a, when it's positive, it opens up, smiley face. And to find the y-intercept, I just plug in 0 for x. I do so, and I find f of 0. Okay. All right, how are we feeling on this? Thumbs up, sideways, down. Okay, okay. And it's like I saw 3/4 in there. It's okay. All right, so we have this. Now watch how quick I can graph this. I go in here. I know that the y-intercept is at 0, 0. My vertex is at -2, 4. I'm going to put a B so I remember that's what it is. It opens down, so I know that I have a line of symmetry, kind of right there. Because this is 2 over, I know that it's 2 over on the other side. Here's my other point. Ugh. You guys get the point? Sorry, I missed a point. All right, so this is not, there we go. All right, really quick to graph. It doesn't have to be perfect. I want you to just note those main points. So I was being thorough, like on a test or quiz, I put -2, 4 for vertex. I put 0, 0 for the y-intercept. And that would be a good amount. Is this a minimum or a maximum?
Maximum.
Maximum, because it's at the top. Okay. So this is also a max of 4. Okay, that's the last step. I don't want to spend too much time on the graphing part because we did a lot of that last week. If you have an issue with the graphing, then there's not too much time. Maybe try to do classwork number 3 and ask me to come over and help you out with that. Okay. How are we feeling about this? Do we need, who wants to see another example problem that I can do while you're working on classwork? Anybody? Going once? Okay, cool. So I'll do that, I'm actually going to do it on this side.
Oh, page 29.
You need one, Jim?
That makes a hell of a lot more sense.
What's that?
223.
Oh yeah, if you left workbooks or you turn them in the quiz, they're right up here. Go and always come and get them if you're ever missing. There's workbooks, there's books, there's folders. So come get your stuff. Yeah, go ahead and come grab it. Do this one. All right, so we're doing one more sample problem. Let's do this problem right here. F of x is equal to -2.
What's the one that we did last year?
It takes too
X
long.
plus 3
I like this one better.
squared minus 1.
But you can get through it faster.
Okay. So, yeah, any of these are all All right. So looking at this, what's my A value? A is -2. What's my H value? This is the crux. So remember, when it's positive, H has to be.
We're getting the y-intercept.
Yeah.
Is this in unit?
It's in unit. Oh, number 3.
What's my K
1,
value?
2, 3, 4, 5, 6, 7, 8, 9, 10.
-1. It's just whatever this value is up.
3, 7,
Oh, that's easy.
3, 7, and 10.
We know this now. What? A is negative, so I know it's after 7.
So if it's negative, then it's
So
positive,
think,
right?
remember this, when A is negative. Remember that? So we made that trick where we had the circles. When A is positive, when whatever my value for A is.
So would H be 1
If this was positive, you have to face, but it's -2.
for number 3?
Yeah.
So we know it's facing down. All right, vertex, we can do this real quick. Vertex
K is
is
10.
H, okay?
So you want us to graph this?
No, I want to go ahead and I'm just like.
All right, and then we need to find the y-intercept. That's going to be the last bit. What did we do for the y-intercept? We plugged in.
And you always plug in 0, right?
That was 0, -2,
Wait, this
0,
one doesn't matter.
3 squared minus 1. It's going to be nice because watch how quick it just dissolves.
So that's great. Number 3.
First bit. Negative 18 minus 1, negative 19.
Okay, so we sacrifice.
So I just figured out that it's at 0, negative 19.
Stop coming.
We got this. We got that. We know it's that. So we can grab that really quick.
So actually the hockey players really
Y-Intercept, watch what I'll do. Negative 19. Not doing it. Vertex, negative 3.
What the heck? How is it played?
Negative 1.
Wait, how is number 3? How is
Opens down, so I know it's going to look like that.
negative? How is H1?
This distance.
Oh wait, but
negative
negative on the negative. Stupid.
But it only asks for the vertex and whether it's a max.
Still gonna do it.
Better. What's the hardest part? That roll. Okay. This is mostly helpful with the shortcut. Okay. So depend on the shortcut if you need to, but it's going to start.
It's easy. You just gotta.